Section 2-3 is on conditional statements. A conditional statement is a statement that can be written in the form if, then. The hypothesis is what follows the word if, and the conclusion is what follows the word then. We can use symbols to express this, where P is the hypothesis and Q is the conclusion. And this little symbol here, P with the arrow going towards Q, is read if P, then Q. What that means is if P, the hypothesis, is true, then Q, the conclusion, is also true. So here's our first example. Identify the hypothesis and conclusion of each conditional statement. If it is Wednesday, then I will wear a dress uniform. So the hypothesis is it is Wednesday. Notice the hypothesis does not include the word if. And the conclusion is what follows the word then. I will wear a dress uniform. Okay. Please note, I'll write it over here so you remember. If and then, the words if and then, are not a part of the hypothesis or the conclusion. So don't put those in there. Example number 2. I will sleep in if it is Saturday. The hypothesis is, it is Saturday. And the conclusion is, I will sleep in. Okay. Notice that sometimes the conclusion comes first. You have to kind of think about it and figure out which is dependent on which. Often conditional statements are written without the words if and then. An example of this is the statement, a square is a rectangle. The way you would write this in if-then form is to say, if a shape is a square, then it is a rectangle. And notice I've identified the hypothesis by P and the conclusion by Q. Now, be careful when you're doing this. I don't want you to use the word it unless you tell me what it is. The temptation might be to say, if it is a square, then it is a rectangle. You can't really do that grammatically correct. If a shape is a square, if a polygon is a square, if the symbol is a square, then it is a rectangle. Be sure you're using a noun there, not a pronoun. Here are some examples to try. Identify the hypothesis and conclusion of each conditional statement, then write it in if-then form. Actually, I think it's a little easier to write it in if-then form first. The sum of the measures of two supplementary angles is 180. So putting that into if-then form. If two angles are supplementary, and I'm going to abbreviate here, then the sum of their measures is 180. Then the sum of their measures is 180. Actually, maybe I'll move this over a little bit so I don't grab the word if, then in there. Okay, so two angles are supplementary. That's my hypothesis. I'll label it P. The sum of their measures is 180. I'll label that Q. Example number 2. A 5-sided polygon is a pentagon. Put that in if-then form. If a polygon has 5 sides, then it is a pentagon. Please don't say if it has 5 sides. If a polygon has 5 sides, polygon has 5 sides is my hypothesis. It is a pentagon is my conclusion. Note that most of the time, but not always, the subject of the sentence is the hypothesis and the predicate is the conclusion. Make sure that not always, but make sure that the conclusion depends on the hypothesis. The conclusion must depend on what the hypothesis was. A related conditional statement is called its converse. The converse of a conditional statement switches the hypothesis and the conclusion. The conditional statement is, if P is true, then Q is true. The converse switches these and says, if Q is true, then P is true. Here's an example. The conditional would be, if a polygon has 6 sides, then it is a hexagon. Polygon has 6 sides is the hypothesis. It is a hexagon as a conclusion. To write the converse of that, I just flip the conclusion and hypothesis. If a polygon is a hexagon, notice that was my conclusion in the first statement, then it has 6 sides. Notice that was my hypothesis in the first one. Oh, and here's where I wrote a note. Don't use the word it in the hypothesis unless you've told me what it is. Okay, that's just a good grammatical way of writing and speaking. There are 2 other related conditionals called the inverse and the contrapositive, but we're not going to focus on those in this chapter. Please note that sometimes the conditional will be true while its converse will be false. So the conditional, the original statement, can be true, but then when you flip the hypothesis and conclusion, you can end up with a false statement. Here's an example of that. If a polygon is a square, then it is a rectangle. All squares are by definition rectangles. The converse of that, if a polygon is a rectangle, then it is a square. That is not true because not all rectangles are squares. So here's a few examples. Write the converse of each true conditional statement, then determine whether the converse is true or false. If false, provide a counterexample. So in order to write and here we have the example, angles that form a linear pair are supplementary. In order to write the converse of that, I think it's going to be easier if we write it in its if-then form first. So the conditional statement would be, if angles form a linear pair, then they are supplementary. Okay? It's going to be easier to write the converse if I write the conditional in if-then form. Okay? And just to highlight it here, there's my P, here's my Q. Now to write the converse, I'm going to flip those 2 around. If 2 angles are supplementary, don't say they, don't use a pronoun until you've told me what it stands for. If angles are supplementary, then they form a linear pair. Okay, so all I've done here is flip, oops, I forgot to label that Q. I flipped my hypothesis and conclusion. Okay, so my conditional statement is true. In fact, most of the time they will give you a true conditional statement. Now we have to determine, is my converse true? If angles are supplementary, then are they a linear pair? Do they form a linear pair? No, that's not true. That's actually a false conditional. So while the conditional can be true, the converse is false. And give a counter example of that. Well, here are 2 angles that are supplementary. But they do not form a linear pair. So I could say measure of angle A plus the measure of angle B equals 180. Therefore, they are supplementary, but not a linear pair because they don't share a side. So 2 angles can be supplementary but not necessarily form a linear pair. Here's another example. A 45-degree angle is acute. Let's write the conditional in if-then form. It'll make it easier to write the converse. If an angle measures 45 degrees, then it is acute. Okay. If an angle measures 45 degrees, that's my hypothesis. It is acute is my conclusion. To write the converse, I'm just going to flip those two. If an angle, use a noun, not a pronoun, is acute, then it measures 45 degrees. Okay. Is my converse true or not? If an angle is acute, then it measures 45 degrees. No, it's not. That's false. And I need to give a counterexample. Okay, I'll just draw a little angle here. A good counterexample often involves a picture. Okay, so here's angle A. Angle A is 30 degrees. That's an acute angle, but it doesn't measure 45 degrees. Angle A is acute. The measure of angle A is 30, but it does not measure 45 degrees. So sometimes, even though your conditional is true, your converse may not be.